Good afternoon. In my presentation, I will talk about open codes. I will talk about open codes. My talk is about that. And meanwhile, I want to forewarn you. This is the developers conference of software engineering. But when I talk about open codes, not only software with open codes, but hardware with open codes as well. I'll touch upon that issue. Yeah, as I work at the development sector and I participate in the verification of processors, and I use free software. I use it very widely, what we call Linux, for example. And I work at Nisiran. I've been working for 10 years, and several generations of those processors changed. ComDiv, AK architecture, ComDiv, but simultaneously. I work outside my office hours. I contribute to many projects, to develop free software, which is based on Linux, the most famous one, Linux, and very much in demand. Then I'm one of the main developers of Bearbox uploader, and then we're using it in Nitiran at our research institute. Then I have I've been sending patches, so probably the best emulator with open codes that's called KEMU, and then I contribute to OpenOCG. This is software for inter-circuit chip tuning. So that is why, So I try to combine both. So what I have to do at my work and outside my work, so I work as well. So May last year, in 2015. Mr. Panchev suggested that we participate in MIPSfpga. So he spoke about that in his presentation. I will repeat a little bit to understand it better.
Imagination provides for training purposes to the faculty and students non-obfuscated core MIPS. With the source codes, they provide the manuals, what you can do with them, so that you could arrange a training process around them. So I got involved, though I'm not a developer, because it's rather meant for developers. But I decided to try the role of the hardware developer. And I want to thank Robert Walls and Yuri Panchin who let me participate, because formally I did not. I was not eligible. I was neither a student nor a professor, so I was permitted to participate. So why my interest? If you get the source codes for the processor core, you just want to try to connect some open source hardware. I heard there is an open course website that accumulates IP blocks that could be connected to the MIPSfpga core and see what happens. I did this test, and after it, I got this publication at Habra. And what was the idea of my test? So the system that jury suggested for lab activities, I connected open course IP block word for transceiver and remitter, and then I used my experience as a loader Barry box to embed this little component to the system on Crystal and demonstrate the system working like that. The Nano monitor is very convenient. It now takes less than 1 kilobyte of code and can easily be put into the smallest memory. It does not require any memory. It makes my life simple. So I made this simple system, and in this way I got this experience of a hardware developer. And what would be the lessons learned? And MIPSfpga is a wonderful product that I never had before, and I wanted to participate very much. In order to get involved, I had to work with the profile forum where people gather who are interested in programming. So, and talking to them, I saw that many of them would like to work with it. So I worked with it at home. So I did not use any resources of my institute, but I consulted some people so that they would explain it. So there is every cloud has a silver lining. I don't think everything is so good. There are restrictions. Only the faculty and the students can work with it. The people who are not employees or students do not have access. They require and you need to comply to non-disclosure agreement. Means that if I have introduced some changes, I cannot show it to the people who are interested. And besides, the instruction that are actually mean that you should use very expensive boards that are not available in Russia. For instance, I had difficulties purchasing them. Then MIPSfpga, the lab, is kind of tied to special software. In particular, Yuri provides a set of software, compilers. He uses Windows, and I didn't like this. I prefer open source. I would prefer Linux for this lab, and there is no chance to connect to IP blocks from open source. It's not difficult, but initially it was not there. So I think that MIPSfpga is a good thing, and many issues could be addressed if more open source components are used. Then when I finished MIPSfpga activity last December, there was another project with MIPSfpga, and where you could do SOC with blocks on SA links. Let's have a look. You would be given the MIPSfpga core, and then you only use IP blocks, links that are not permitted for distribution and that are only linked to links. You can program with a mouse and assemble those squares, but I didn't like that tight connection. What would be the components? So they're not in free access. So the core MIPSfpga, if I introduce some changes, it means I can only show them to a very restricted circle of people. And as for MIPSfpga SOC, I will be linked to XI links. And I don't know what additional issues we might have. So this is a very serious restriction, and I could do nothing to it. That was the main issue, and now more to the housekeeping issues. For the students, they suggest quite expensive boards, and they are so powerful that you need maximum 20% of their capacity. And I didn't like that. I found a local boards producer offering simple boards at very good prices. That's Marsohod from Taganrog, Russian city, and they would send boards by mail. And besides, they have a website with special instructions how to handle their boards and many interesting things. And there is a forum as well. If you have issues, they will help you. This is all great. And I have found a nice board that cost me several times less than they offer officially, and I used it. Then again, software. MIPSfpga suggests using special code escape, and I think it's better to use the one that is included in the distributive core, but it's easy to download and install. And in MIPSfpga, they don't use emulators, but in our institute we use them a lot. I understand why they don't, because that's additional trouble, and probably they don't really want it. But I think it is necessary, and instead of model sim, that is a proprietary product, you can easily use the open source software. As for the hardware, I found a free MIPS core that you can use instead of MIPSfpga. In the wishbone bus can be used, and many IP blocks would be distributed with wishbone bus, and to use them you need to provide support for this bus. And the simplest software exists. You don't need to connect it manually, as I told you. You don't have to use expensive boards. You can just use the most reasonable option. Have I exhausted? Yes. When I was applying for this conference, I was told that it is a wonderful presentation, but absolutely murky. No technical details, and in order to consider, I decided to break it into two parts. In one of them, I'm telling you the heart of the matter, and in the second one, I demonstrate how. I make a demo, and out of this demo, the key technical details should be quite clearly seen. So let me tell you about this processor core that I used for MIPSfpga. And if I needed to give it to a person who is not savvy, who does not have the right for MIPSfpga. So within the old project on creating multiprocessor system in Utah University, they developed this core, and this project is over, but the core exists. It's more or less done, and I took it. There are options, but for instance, there is MIPS Plasma, but I didn't go for it because it was written in VHDL language, and I have bad relations with the MHDL. So this core is very simple, doesn't have cache memory, MMU, no coprocessor, but it's the smallest one, the simplest. It's almost half the size of MIPSfpga, and I could get this core into the simplest boards. MIPSfpga did not fit. Within open cores it started, and a thing like FuseSoc, that is assembly SoC system from IP blocks. When you set up configuration, you list what you connect, and script FuseSoc will make the switch, and there is no risk, no error. Traditionally, this FuseSoc would be used for the OpenRISC core with its own command system, and I think it's fine if instead of the OpenRISC I will put MIPS processor. So this is a demo system that I made. It confirms that my approach is quite practical. You can make this something similar to MIPSfpga, and you will be free from the MIPSfpga problems. So this is it for my theory, and I would like to start the demo and tell how I do it. So look at this thing is. I have here something you can touch with your fingers. This is the Marsahota board that costs 10,000 rubles. The largest chip, the largest board with a programmer, and you can connect it to your favorite TV. You have LED indicators, and you have the pins for extension. You can connect another module for this to this board. I will not use it for the demo, but I will use a simple one costing me 4,000 rubles. Let us have a look what exactly I'm showing you. In my system, we have a board that we're going to program. For programming, I used Raspberry Pi. Raspberry Pi would be connected through the interface for programming, and UART to look at the software. And then Raspberry Pi controls the power, and it would be used for turning on and off, program and have a look, and then turn off. And then in my demo, I have a relatively powerful notebook of yesterday with x86, where I shall launch all the CAD. So as I will be give the results to Raspberry Pi. So this system demonstrates how we handle in our institute fine-tuning of processes. If you have something that you cannot assemble, then the software developer's efficiency drops, because the processor should go from one developer to the other. And if you just don't do that fast, you will delay. So you're getting a chance to work with your board out of your home. So I have the board, I have the Raspberry Pi, and other components, and I shall briefly tell you about this demo. I'll tell you what free software I use, open source. I want to use Debian Linux unstable testing, because in this unstable testing there is the MIPS toolchain Qemu emulator that I complemented by the Crystal, and I'll use Bearbox to demonstrate the supply, and Icarus Verilog to emulate SOC on my laptop, and Quartus 2 from Altera, the only proprietary software to synthesize the thread, and Raspberry Pi, OpenOCD, and Minicom to watch what's going on. So, before I demonstrate, I'll tell you briefly what I'm going to show. As I told you, I think it is important to use the emulator working on SOC. So I start with preparing QEMU. Then I launch the software, check that it works. Then I check that it works by modeling Verilog, Icarus Verilog. When I make sure that it's good, I will call Quartus and generate the thread that I will send to Please through Raspberry Pi and see what happens. And as a separate question, I shall consider how SOC generates the switch, how if it is simple. And if, for instance, I want to connect to my SOC another block with open source, then this operation will not be something difficult. It will happen quite simply, and I will demonstrate it. I'll show it by removing SOC system. So the slides are over, and I'm starting the demo. Now you are watching what's happening on my notebook. All the operations I told you about, I recorded, I performed, recorded, and some of those operations, like synthesis, may take some time. Therefore, I shall show you the records and comment. I use the PTI Play software in order to demonstrate my records. So I'm showing, if you don't believe that I'm using Debian testing unstable, I have installed some chain, and I have the latest compiler, DTZ6, and I have installed the latest set, and I'm starting getting my emulator. I have placed my emulator on GitHub, so you can always just copy what I'm doing. I shall download it quickly from GitHub. And then I assemble the emulator because I need not the one from the website, but from my board. I'm just scrolling it quick. Yeah, I'm not singing live. I told you, this is a record. So please, just bear with me. No, it works in groups. But the philosophy is such that the proper software should work. So you have a chance to ask more questions. I have checked. I have the latest QEMU, and now I'm assembling the software, and I download the Berry box loader. Bearbox is similar to the Linux core. It's very convenient because it's Linux is more difficult to understand than Bearbox, but infrastructure is similar. And now I just launch it, and you see that even it wrote something to my port and reads something. I'm convinced that my software works under the emulator. So next step I make, and I made this image that can be sent to CAD. So So I start modeling like an adult. So I download. I take the image. I get the image and start modeling for Icarus Verilog. And then I launch the assembly of the broken thread. And it takes 3 minutes on my notebook. For comparison, for the processes that we develop in our institute, sometimes we need 4 hours, 8 hours. And 3 minutes is next to nothing. Let me show you how we model. So I have all the scripts. And that's how we model Icarus Verilog. Microseconds it takes, and then we render it quite nicely, and then we have the cyclogram, and I'm interested in this chain. And I see that I have some number of commands from the processor, and then some symbol is getting out. It means that's good. I can look at the bits that are out and can use it further. So it was modeling, and now I keep Wishbone. I save it for later, and then let me show you how I work. I have a special window prepared here, and this Raspberry Pi console. So I'll tell you what I have in the box because you cannot see. I have Raspberry Pi and a relay module. So through a special wire, I have the board connected to it, and it allows to turn on and off the power, the blue one. But the black wire is used for different purpose. Let me see if I can turn on and off. You see, the light is on, but I can off it. Now let us load the bit flow. So it's OpenOCD, and this script I got pre-cooked here. The script is great. Let us see what happens. My light is on, and I wanted to turn on the web camera because I use it because I want to see remotely if the board is all right, but I shall be looking at it here. So we are downloading that thing. It loaded 17 seconds. That's my program, just like on the emulator. And this is almost it for the demo. And I wanted to show you how FuseSock works in generating the wishbone connecting the blocks. So it is a simple and brief demo. So I'm going to the source codes and showing you that there are no changes. Then I shall show you how the file looks. It looks like that. Sorry, I jumped over, but I'll show you separately. I shall try to repeat all this demo. You see, good that I recorded it because I cannot do it manually. So that's how the wishbone configuration looks like. So it is very brief.
In my system, we have this master is the core, and then we have two. You can see them on the picture and the art. And so now just I'm going to this configuration file. I have changed it. Now you see that I threw out. So this I just have thrown it out. Now I need to reconfigure it. I need to reconfigure it. My contact. So I've done it. My switch, and what do I have here? So besides changes in the configuration, 4 lines, we have lots of things in the fishbone switch. Lots of. If I did it by hand, it would have taken much longer. So that is why. So thank you. That's it. Questions? Yeah, there is another one. I knew that it would die. That's why I've given you another one. I have many questions, but I wanted to start with a short comment. It has nothing to do with open course. It's an old host, and VSOC developed differently. You are right, but that it's a more complicated history. So there were people that lived there, and then they went, and there were some clashes. Open course, I can speak about open course because I've not been watching their infighting. I was not interested. My question was, you said that it's good to use open source, And I like this initiative of imagination technologies vis-a-vis MIPSfpga, FPGA Mix, but there are other open source solutions, and so I like this MIPSfpga. So there are others, Milestores, Decaloft, and others, and so they're good too. About the Echo board, I tried to collect them, and it actually broke down at the level of the switch. The second one, it doesn't support some certain constructs, do them by hand. I decided to wait until he rewrites it himself, and I will use his results. And then Wicca board, as a please, is only for 8,000 valves. Yes, very small please, very small please. I don't think I'll be able to fit into it anything worth fitting. Yeah, okay, any more questions? You were named for MIPSfpga. Some very expensive boards, 300, 500. At our southern university, we experimented with MIPSfpga. It's a D0 ZCV, so it's about $100, and it works well. And so then there's another model. It's $50 only, and we don't have it. But FPGA project, and I tried to make this board, and actually it could just get into it. So then a board for $500, we don't need them for MIPSfpga. I think that's cheap boards are sufficient. It works very well. So look, this publication. If you look at this, it's just exactly what I wrote. So because I replaced them for the three zeros, the cheapest board and the board that you spoke about. I tried. I agree with you. It works. Yes, but you use cheaper boards. I agree. Yeah. Yeah. And the last question. Three small comments, corrections rather. First, you can easily use a DCC Turchin for writing this program, and so MIPSfpga. So I can use this Codescape. Using Codescape is something you can download and use right away. So you don't have to use this FPGC. And then second, MIPSfpga can be used for Linux and other tools that are hosted on Linux, and easily. And so the only thing that you need to do to add to it is shell scripts for the software download. And in my view, it's so that's a couple of lines of shell scripts. I can give them to you on Windows. And the third is that the most important, Anton was saying about this course, how to use this course, and this is all great. And moreover, I personally think that to teach students is better for them to do the simple core just in a few hundred lines. So to understand the concept of the conveyor, the stalls forwarding conveyor, to understand this, and so then they could use the core that is used in industry. So in MIPSfpga, it shares the code with the core MIPS VP 5100 and some MIPS M4KC. And these cores and Minecraft VP now they're using Samsung engineers use them for the development of Samsung RTK1, and the microchip technologies engineers use the same for the development of different options for microchip PIC 32MZ. And also more than 100 companies have used this approach, and so it means that it's been run many times and it works well, very reliable. And so the basic concepts are there, and we can use actually what the engineers of advanced countries work with. And so MIPSfpga is used with a number of university courses, and so can very compatible and can be applied. And so it means between these two extremes, so the simple student approach and industry approach. We need just to say here the whole variety of different things, what kind of course to use. So let's applaud, give a round of applause to our speaker. And so next